Solve the integral of cosine to the fourth power of x. Now, I just wanted to draw your attention quickly to the fact that there's 26 days left in this maths countdown series. So there's a lot of maths that we're going to be covering, and there's a lot that we're going to learn. And so make sure you stick around to see what I'm counting down until. All right, so back to this integral. Yesterday, I did the integral of sine to the fifth power of x. And I told you that when doing integrals of this nature, trig integration, where you have high degrees of x, you should take out one of those trig ratios. So for example, sine to the fifth power of x, we took out a sine of x and we left that by itself, and then we had sine to the fourth power of x. We eventually manipulated it so that we could make a nice substitution. Now, when we have even powers, it's slightly different. So when we had odd powers, we use our trig identities such as sine squared plus cosine squared is equal to 1. But now when we are using integrals to even powers, it's more beneficial to use our double angle identities. So for example, cosine of 2x is equal to cosine squared of x, 2 cosine squared of x minus 1. So I'll show you how this is useful. So the first thing we're going to do with this integral is we're going to take out or have a cosine squared of x squared, because it's the same as cosine to the fourth power of x. What I'm saying is we have the integral of cosine squared of x squared dx, and you can see that's the same thing. All right, so what this allows us to do is to re-express cosine squared of x in terms of its double angle. So if we isolate cosine squared of x over here, we get cosine of 2x plus 1. I take that negative 1 across, then I divide by this 2, and that's going to be equal to cosine squared of x. All right, so now if we re-express this integral, it'll be the integral of cosine of 2x plus 1 all over 2, and that all squared. All right, now when we're squaring this, we are basically squaring the numerator and the denominator. So if I square the denominator, it's going to be 2 squared. So I can take out 1 over 2 squared, or 1 over 4, because it's a constant. I can take that out my integral. So I have 1 over 4 into the integral of, and now my numerator squared. So what is this numerator squared? Well, cosine of 2x squared is cosine squared of 2x. And then we multiply them together, cosine of 2x and the 1, and that'll still be cosine of 2x, and then we multiply that by 2. So it's plus 2 cosine of 2x, and we square the 1, so it's 1 squared, which is just 1. All right. But now you'll notice that we have another square over here, which may seem problematic, but it's not problematic, and I'll show you why. So we had this identity initially with cosine squared of x, but now we have cosine squared of 2x. So every time we see an x now, we're going to replace it with 2x. So we also have to do that over here. So we replace that x with 2x, and if we have 2 times by 2x, we can replace it with 4x. All right. So we have 1 over 4 into the integral of, now instead of cosine squared of 2x, we're going to write this, which is cosine of 4x over 2 plus 1 over 2. And then here we can leave that, so plus 2 cosine of 2x plus 1. Now you'll notice that 1 over 2 and 1, they're both constants, so we can add them together, get rid of that, and we can write 3 over 2, because 1 plus 1 over 2 is 3 over 2. Okay, so we're pretty much ready to solve this integral now. So we have 1 over 4 into. Now, the integral of cosine is sine, because the derivative of sine is cosine. So we're not done though. So we have cosine of 4x over 2, and we do the integral of that. So we have sine of 4x over 2. But what about this 4 that was inside here? So reversing the chain rule, we're now going to divide this sine by the derivative of what's inside cosine. So we are dividing sine by 4. So 2 times by 4 is 8. So our denominator is now going to transfer to 8. So the integral of 3 over 2, that's 3x over 2. And then the integral of this, similar way to how we did the integral of cosine of 4x over 2, we have now sine of 2x times by 2, we keep the constant, then we divide by the derivative of what's in our cosine. So we divide by 2, and those 2's cancel. Then don't forget plus c, the constant of integration. All right, so now all that's left to do is express our answer and expand this bracket. So we have 1 over 4 times by this, which is going to be sine of 4x over 32 plus 3x over 8 plus sine of 2x, That doesn't look like an x. Sine of 2x over 4 plus c. And that is the integral solved. I hope you found this video useful and interesting, and if you did, please don't forget to leave it a like and subscribe to my channel. Thank you for watching.